Hello, how are you doing? Hi, everyone.
Hello, Professor.
Hi, Sam. How are you?
I'm good. How are you?
Good, thank you. Welcome back, everybody. Sorry, I thought I had turned on the module, but I just did right now. Um, so you should be seeing Unit 10 on your Canvas now, and that's Chapter 13. We're gonna catch up with the lab, so we're doing Lab 9 in Unit 10. So it's labeled a little funny. I will change the document name after this. So we have about 4 more chapters to go, which is going to take us to Unit 12. So in the next week, we're going to do Unit 11 is going to be Chapter 14 and 16. And then Unit 12 is going to be 17 and 19. And then in week 13, I will cover final review. And I will give you time in week 14 and 15 to finish your project. So we will wrap up everything by week 13. Okay. All right, let me screen share. If you have the notes, you can go ahead and open that, and also your assignment, you can download that as well. Get my notes up here. So this week we are going to touch on control statements and looking into how we can apply this to our project. Let me get my, okay. So we're gonna tie the concept to C programming so you can understand it a little bit better, as some of you have taken classes in C++. So let me screen share real quick. So I don't normally use PowerPoint, but I think the PowerPoint for this week is actually not bad. So in this, we look at how C programming would be when we need to write control statement. So in control structure, we normally would have conditional statement like if else, and in the case of C++, you also have a switch. This allows us to branch based on decision making, and it's gonna let us execute depending on the evaluated expression. If the expression is true, then it's gonna execute. If the expression is false, then it's gonna continue to the next line. And we have worked with a for loop and a while loop in assembly. So similar to assembly, you would see this in C programming, where we would have iteration implemented in a loop. And so if we need something to be executed multiple times, then we would implement a loop. So in the case of a for loop, we would have it execute up to the maximum number that we set in a for loop. So in C, we would see this as a while, a for, a do while. And other languages, we normally don't have the do while. We see while and a for, like for Python. So Ethan has a question, do you know when the result for the fellowship come out? So just side note, right, the fellowship application has been submitted, and I think there's like 115 applicants. UCR has reached out to us about setting up the time, and they wanted to meet during spring break, so we wrote back and mentioned to them that we have spring break. So I'm waiting on UCR to schedule a time so we can go over the finalists for the application for the fellowship. I'm hoping that it's either going to be this week or next week, but I will follow up with UCR tonight and I will have a date for you sometime this week, maybe by Thursday when we meet again. Okay. So it all depends on their schedule as well, but we were supposed to nominate the finalists and then go through that. So once UCR decided on, who are going to be the fellows, then you will get an email from either UCR or us. I think UCR faculty is going to send. So you're welcome. So I should be able to get an answer for you this week or at the latest early next week. So it all depends on when they're going to respond to my email. All right, so coming back to here, we talked about having loops like a while and a do while and a for. So that's if you want to iterate and execute multiple times. So when you write your documentation, you're required to do a flowchart or pseudocode. Make sure you implement branching in your pseudocode or flowchart. So in the case of an if, right, for the if condition, the expression needs to be true for the action to be executed. And in LC3, we would see this in branching. We would implement branching, and most of the time we would subtract a value and branch based on what we're trying to evaluate, whether 0 or positive or negative. So in C, if the expression is false, it's going to branch the other direction and it's going to continue in the next line. So now for LC3, if the condition is true, right, it's going to execute something there. So when you branch, you would branch it to a label. And in that label, you would include the task for the action for it to execute when it's true. Like we talked about this in our lab last week. We talked about how we would branch for is 0 or not 0, right? So today we're going to do a couple exercises where we will implement control statement in LC3. So that way you will have some practice. So if it's false, your next line, so the address of the next instruction in assembly is going to be loaded to the MAR, and the address is going to be the program counter, right? That's going to be pulled there. So it's going to know which line it's going to pick up and it's going to continue to execute. So last week, when we said if it's not true, then we're just going to store the result for the return from our function. If it is true or if it is 0, right, then we are going to shift and not add for the faster multiplication program. So you see that so far we've been working with the control statement and the iterative statement or iteration. So the example that you would see for the if statement like this, and in these example, we would use the comparison operator. So here we would have if x is less than or equal to 10, then y is going to be x times x plus 5. And so when you look at this in your mind, you should be able to say, okay, how do I write this in LC3, right? We load the x label, right? We initialize the x to the 10 decimal, and we load the y label, and we want to make sure that we compare. So we have to branch by subtracting 10. And because we're comparing for greater and equal to, then we can say if it is greater or equal to, so if we subtract 10, we're going to look for a positive value where it would be greater, or a 0. When we subtract 10, it will be 0. So we're going to branch for 0 positive. And so if it is 0 positive, then we're going to load the y, and we are going to a register, and we are going to add, right, the x to that. And then again, we're going to operate the multiplication by re-adding the x. So when you have x times x, that's just mean that it's going to be adding x times. Okay. So whatever the x value is, so if I initialize x at, let's say 12, then it's 12 times 12. So we are going to add itself, right, to represent the multiplication. And then we're going to later on introduce the 5. So in the body of the if statement in assembly, for the condition that is true, once it evaluates the expression, you just simply branch to a label, right? And then in that label, you will operate the task for y is equal to x times x plus 5. And so with that, we can elevate it, and then we can also add in the z for the second example. So if it evaluates to be greater or equal to 10, so it's going to be positive 0, then we're going to branch to the label. We already talked about y. Then we're going to load z. And when you look at the equation like this in assembly, you would then work from the inside out. So you would then need to operate the y. So whichever the register that you load for y previously, you're going to use that register to make sure that you operate the multiplication for 2. Now, if you implement the multiplication function, then you need to call that at the beginning, and then you need to jump to that, okay? But if you don't, you can simply just use arithmetic. So whichever the register for y, then you just need to implement the multiplication for 2. Then after that, you would divide it by 3. So when we divide, we just subtract multiple times. So we would operate the subtraction of 3 to represent the division. And so in that label section, you would then have what y and z is equal to, okay? So for me, I like to implement functions so that way I can reuse it. And you've seen how multiplication and division function has already been done. It's a little cleaner. It makes your code a little bit more efficient, and so on. So you can think about even on the control statement like this, we can simply use function to operate something that will be repetitive, like multiplication and so on. And with multiplication, we have to think about x and y could be negative value, right? And so, and then when you fill, you just got to make sure you fill what x is, what y is, what z is at a certain location. And also, if you want to save and restore, you have to think about that as well. Okay. So these are a good example for you to think about if you want to practice your LC3. Then in the next part here, right, we are using the AND operator, the OR operator, and also we are doing the increment, okay, and the comparison. So we're going to do some of that today. So I'm going to pause here. I'm going to come back to the assignment here. So in the first question, it asks you to describe the use of conditional statement in C programming. And it is used for decision making, which allows the code to execute based on evaluated expression, true or false. So if it's checked true, it's going to execute. If it's checked false, it's going to continue to the next line of instruction or the next line of your code. And control for the conditional expression in C, we would see that it's used in if else, and switch. Now in other languages, it's slightly different, right? Like for example, in Python, you have if else, if elif, right? And Python doesn't use the switch, but in C, you would have these 3. if else, and switch. We also talked about iteration, and that's when we implement looping. So for 3, it asks you to describe the use of iterative statements in C programming. This is used to execute code multiple times, ending based on evaluated expression. So in a while loop, it would exit, right, when the condition is false, and it keeps going if the condition is true, or the expression is true, I should say. In the for loop, it would exit based on the maximum value that you set it for your counter. So in assembly, when we did the for loop, we would initialize the decimal value as our counter value. And as we loop through, we need to decrease, right? You have to count down. You would count down and then you would branch, because when you reach 0, then you have to let it exit the loop. Okay. Just like how when you use a for loop, every time that it loops, it subtract 1. And so when you get to the end, right, it would be your base value, which is 0. So in a for loop, there's always 3 parts: where you start, where you finish, and how you update. So the concept is the same in assembly as it would be in other programming languages for our loop and our conditional statements. For number 4, it asks you to identify the types of iterative expression in C programming. And for C, it would be while, do while, and for loops. And so consider how you set up your project. If you're using a loop, right? In assembly, we don't really have a way to really distinguish one loop with the other. It depends on how you want to use your label. So you can use your label, like call it a loop or a while, right? However, it would be easy for you to identify what that section of your code means. And you would set up the operation for that loop and think about how you branch. So in our for loop, we talked about this: set up your counter, decrease, and then branch and when it gets to 0. Okay. In the while loop, we have to think about how it's going to exit the loop. So you would need to set up the operation and then set up the branch so that way it can exit. Now, in the case where if we want to use a continuous while where it's never ending, right? Like how you would prompt the user with a program just keep on running, it doesn't stop, then we can think about how it's just going to come back and reload, right, the string and keep asking the user to input. And some of that you can see in your project. It depends on how you want to approach that, okay? Any question with the general concept for control statements or control structures? Okay, so in some case, we might need to nest, right? An if inside an if inside a while, right? And so on. So that means that for assembly, we still have to think about how we would use the branching here to evaluate this expression. Okay, then it's gonna go into the next if, so we have to nest it within after this branch is met. So then if, let's say that I evaluate x here, and if x is equal to 3, So you can send it to the equal label. And in that equal label, then you can set up the expression for this. So we have to evaluate for y is not equal to 6. So once we load the y label, we simply initialize 6, we subtract 6, and we would branch it for what? We cannot branch it for 0 because it's not equal to 6. So if I take 6, subtract 6, right? I'm going to check for what? Positive or negative, okay? So I would check for P and N. So I would branch for P and N, and then I would send it to another section where I would load Z, and then I would add 1 to Z. I would load W, and then I would add 2 to the W. Okay. And then that would, so after, so you would use the label to handle this, right? And then the next section, which is the body of the nested if. Any question with that? Okay. So here is the example from your book or the authors. Okay. So here we are evaluating the expression x is equal to 2 and y is equal to 5. Okay. Now they're using the LDR, that's register load. So here we assume, right, that x is already loaded to register 0, or x is from actually register 5. So they simply load x into register 0 here from register 5. And to evaluate this expression, remember, we're going to work from the parentheses outward. So we are going to subtract the 2 from x, which is in register 0, and we're going to branch. Okay. So in this case, they're going to branch to not true. So when you take any value, subtract. So let's say if I take 2, subtract 2, I would get a 0. So I don't want to branch to 0 for not true. Okay. So I have to check for negative and positive. So if it is non-zero, then x is not 2. So when using the not true label here, we want to send it to not true, and assuming that we would have additional, right, execution, then we can set up the body of your if in the not true label. But you still have to work with the y. So we would then load, right, y, or in this case, they have it in register 1. So they store, this section store y. So here, right, is a, they clear R1, and then they're going to add 5 to R1, which allows you to initialize the value here. And then they store the R1. Now, you don't have to do it exactly like this. I would approach it a little bit different. Okay. I would do the load y, and so that way I can check the y value and fill it. And then I would add the 5. Okay. And then I can store that out. But, this is only a snippet. So we need to, expand on this a little bit more for what we want to do with that if statement there. Okay. All right. Any question with the LC3? Okay. So for the if else, it's a little bit longer when you're doing the if else. So in the if else, if the condition or the expression is true, right, it's going to action the if here, this part. If it is false, it's going to send it to else, and then it's going to action the else. And they note here that else allows choice between two mutually exclusive actions with the retesting of the condition. So when we look at that in LC3, in this example, we would say if X, then we're going to increment the Y and decrement the Z. Else, we're going to decrement the Y and increment the Z. So it's the opposite for the else. So assuming that X is in register 5, we're going to do a register load. So load X into register 0. We're going to branch to else checking 0. So if it is 0, we're going to send it to else. Then if this condition is not met, it's going to continue here. So we're going to have to load, right, and increment the Y. So here, what you see is that we would take our 5 and we would load that by subtracting 1 to our 1. And then we would add 1 to our 1. And so our 1 has Y. Okay. So in order to do the increment, we have to do a +1. And since we did an LDR here, we have to do an STR there. So we would then store with an increment of 1. Okay. And then again, we would do similar things to the Z. But when we load this, we would then need to load from register again. So from register 5 and into register 1. So they are reusing the register because they already stored that out. And so when you see the load and the store here, what that is, really think about the memory location that you are using. The increment is really in this line. And similarly to the next part. So we are going to load it to 2 because that's the next one in the memory. Then we are going to set up the 1. So we're going to add the 1 here. Okay. And we need to subtract 2 because it is the decrement. So we have to, when we move 2 up, we have to subtract 2 here for the store. Okay. So whenever you load like this, if you're using this approach, if you start with the load and the value here for the immediate value, when you store, you have to reverse it. Okay. So this is one way, and you don't have, like I said, you don't have to use it this way. But if you visualize that, if that makes sense to you, then you can use this approach. Okay, there are other ways to address this, but okay. And then they would jump to done, and done would be like the next part in your code. Now, this is if it's not 0. Now, for the part with when X is 0, then we're going to handle the else part. Okay. So again, similar to what you've seen here, you're going to do the load and the decrement. Instead of adding a positive 1, you're going to add a -1 because this is a decrease. And since you load at -1, you are going to store at -1. And so for the increment of the Z, you are going to load with the -2, add the 1, and then store with the -2. So you can see the difference when you get to the else portion, right? The values are not reversed. Okay, you're storing with the same value there for the else. Any question? Okay, so let's take a look at a few more examples and then we'll do the next part. So when we're looking at the else, this is, you can think about how you would implement this in C++ or C. And then you can either convert it into LC3 or right away you should be able to do this in LC3. Like in the case we talked about how we can nest the if. And with the else, right? So if the inner if this doesn't check true, then it's going to send it to the else. So you just simply use the label. So I would then, if I load the y, subtract 3, I can check for positive because here it's looking for greater. And then I load the z and I simply operate z divided by 2, right? If it checks for positive, if it is not true, I would send it to the else section where z is going to be z times 2. Okay. If it's checked true, then I just take z divided by 2. So we can simply use the label to handle the inner if and the outer if with branching. And so when you're looking at this statement, if x is not equal to 10, if x is greater than 3, z is z divided by 2, else z is z times 2. And they say that it's not the same as, okay, if you're doing the outer else. Okay, so notice that this else is for the inner if. Okay, so in higher programming language, it is very transparent on how the body of the outer if consists of if, the nested if, and else. Now, when you work with assembly, like I said before, right, you can set up this if, right, treat it as a separate entity, then send it to this if section, okay? Then use the label to handle the condition for the else, right, true or not true, okay? Now, if you're looking at the if and else with only the nested if, where the else is not nested in, right? We still have to set up the outer if. Then we would also set up the inner if. But in the case where it is not true, right? There's no criteria there. Only when this doesn't check true, then it goes to the else. So it is different than this one. Okay, any question? Okay, so here is example for how you can chain your if and if else. Okay, or if and else if. And in this one, they're using the AND operator. So when you're using an AND operator in C, right, when you evaluate this expression, it chain all of these together. So that means that you have, the month has to be 4, 6, 9, and 11. In any case of one of the criteria is not met, it is not true. So the AND requires that all the components needs to be true. All the criteria needs to be true. Okay, so the month has to be 4, 6, 9, and 11. In the case if the month is 12, it automatically check false for one of the condition, and it's going to go to the next section, which is the else if. Okay. We know that it is C because it's using printf instead of cout for C++. Okay. Now, when you're using the OR operator, and you've learned this in CIS 5 and 17, like A, B, C, right? In the using the OR operator, only one has to be met. Okay. So I have month 1 or 3 or 5 or 7 or 8 or 10 or 12. So if I met one of the criteria, it's going to check true. Remember that when we look at the binary level, anytime that it has a 1 for the OR operator, it's going to output 1. So any of these is true, it's going to be true. Compare that to the AND operator, all of them has to be true. Okay, so make sure that we distinguish the difference. Now in LC-3, you don't really have an OR, okay, instruction. In other programming language for assembly, we would have OR, okay, or even sometime, you know, the compound of your logical operator as well. So we mostly use and, add, and so on, but just keep in mind that other assembly languages do use like other operators. Okay. So in this one, we're using OR, so one of the criteria needs to be met compared to the AND. So let's look at a while statement here for iteration. In C, you normally would start with a variable initializing at 0. Then you would check for that variable with the maximum value, right? So you would then, that's easy. I clear out the X. So X is R0, so I AND it. Okay. And here, what they do is they do a store from register to register. So store that register. Then you would enter the loop. So this is now the while. We would load X from register 5. Remember that this is a counter and that comes from the 10. So we would subtract 10. If it is 0 and positive, it's going to go to done. So when we reach 0, because remember, this is less than, reach 0 or positive, we're going to send it to done, which is later. Now for the body, we have to set up the print, right? So assuming that we would have a string somewhere down the line, we can set up the, see, I would do this a little different, but they load the X here from register 5 to register 0 because that's getting ready to do the print. Okay, so you have to do an LEA there. Okay, and then out. So I would do an LEA to the string fill and I would do an out for that. Okay. So for the next part, we have to increment by 1, right? Because you subtract here. So this is for the loop. Okay, so increment the X. Then we would store to R0. And then we would loop back again because it's a while. So we have to jump it back. Send it back to reloop. And so when you look at some of the prior lab, we did do a while loop, okay? And we handle it a little bit different. And so there's, you know, there's not one way to really program things as long as you can get the same output. I normally don't do register load because a lot of the things we use don't just exist in a register. We have to create it. We have to, you know, identify it and define it. So it's a little bit different than what they show here in the text. Okay. And so you can definitely go for the infinite loop, like what we talked about, where it doesn't have a false condition to exit. So in the case we have a continuously running program, you've seen this before in one of my programs where it just keeps running, right? You have to click stop on the simulator for it to end. So if it doesn't, so if you wanted to keep it going, then you can. But in most cases, we want our while loop to exit, depending on your objective. Okay, so for the for, we touch on the 3 parts for the for: where you start, where you finish, and how you update for the for statement. And for C, this is the criteria, right? And that's different in other programming language. So when you think about this, how do you implement this in LC3? Here, what we would see is we need to handle what's inside here, right? How our for loop would operate, where you start, where you finish, and how you update. So we would start with I is 0, so I initialize 0, clear it. I store I, so I is 0 now. Then I set up a loop label, similar to what you've seen in the while, right? Then I'm going to load I to R0. Then because now I'm here at this part, so I need to subtract 10 for my counter. And then I branch to done if it's 0 positive, because this is less than. And then my loop body is going to be that I'm going to load because I previously stored, so I have to load it to R0. I got to load I. And then, I got to clear R0, LE R0 to do the printf here. So you have to do the out to display. Okay, for the body. But I'm not done with the loop because I still have to handle the update part. So I have to do the increment and then the store, because if we load, then we have to store and then we jump back. So it's very close to what you've seen in the while, except for that we have additional parts in how we also initialize X at 0, right? We go X to less than 10 for the while loop. But in the for loop, we have to handle the increment. Okay. So it's going to loop up to 10, right? It's going to stop at 9. 0 through 9. Any question? Okay, so let me see. That's just some example they're asking you. Okay, so you might have a for loop nested in the for loop like this, right? Just like what we talked about with the if else. We have to think about how we would set up the outer loop first, piece by piece, starting from the left, then next, right? And then the outer for the increment. Then we can think about how we would set up the inside. So assembly is, you have to break the components down to the subtask. Otherwise, it's gonna get all mumbo jumbo up, and then you lose track of your register and it's gonna get difficult. So you have to think about how you would handle the inner loop compared to the outer loop. Okay, so we need to set up our counter right after we initialize, and then we can do the update. And then we can check for the inner for loop. Okay. So some of the things that you can distinguish between for and while is that for is a counter-based loop. Okay, it uses an explicit counter variable. We saw that with the 10. Okay, and it's easy to see. So a lot of times people prefer to use a for loop, but a while loop sometimes will be fitting in your program. So while loop is a sentinel based loop. and it's going to check for true or false. And if it's true, it's going to continue. If it's false, it's going to get out, exit. And then you have a do while. So it's going to do what's in the loop body here, and then it's going to test for the while. So the test is when we would set up the while. Okay. All right. So let's do the next one. Okay. And I'll help you. So we saw the example, right? I'm going to do a little bit different than what the authors provide for you. Okay. It's more complete than what you've seen because those snippets are, you know, they highlight the important parts. But so let's say that I have to write LC3 for this. If X is 4, Y is 7, right? We would do something, just that one statement. I would start with the origination address at hex 3000. I load X into register 1. So I did an LDIR1X. Then I copy it to register 3. Okay. And you can handle it directly from R1 and not copy. That's fine because we don't have any additional body here. I normally do a copy because, you know, I assume that X is being used for something else. Okay. So I wanted to keep it intact. So that's why I copy. But you can definitely use R1 and not have to copy for this particular case. So after that, I would subtract 4 to check to see if it is equal to 4, right? And then I would branch it to negative positive for not true. So if X is not 4, go to not true. Then I have to load the Y. So I load the Y to register 2. I copy it to register 4. Then I use register 4 to initialize 7. So here at this point, my Y is 7 or at R2. Then after that, I'm not doing anything else. So I'm going to store X back and Y because I load first. So I store back from register 3 and Y from register 4. And then for not true, since we don't have a body, I just give it a halt. And then I fill X and Y label. And then I do a .n. Let me see if I can move it all up to 1. Okay, hold on 1 second. Let me scoot this up. There you go. So when you look at that statement, one line in C requires 2, 4, 6, 8, 10, 12, 14 lines in assembly. And the way I did this is a little bit more complete, right? I don't use register load and store like what you've seen in the on the PowerPoint slides because right, X doesn't just exist from register 5. We assume that, you know, it's already been loaded in the example that's shown on the slide. So I have to do an LDI and an STI there. You know. Now, to make it more complete, we would ask, what's the body of the if, right? If that is true, what are we executing? So let's say that if that's true, we would take X plus Y, then all you have to do is set up a true section, or yeah, so you would continue here, loading the Y, and then once you do that, you would initialize it at 7, and then you just add it to register 3. And then store it to, you know, like result or something like that, and then fill the result. So that would take care of that one line for the body. Any question? Easy, right? Okay, so let's try the next one if we're ready. So this is from, you can use the slide information. Number 6 is from the snippet from the example. So I just use theirs. But we can make it more complete. I can fix that. Okay, so we can do x1000, and then we can just load. I'm gonna do a load x0 with an x, and then we can clear it. And we can clear 0 or 0 x. X is 0 or x R0. Yeah, I normally don't use R0 because, you know, in the case if I need it for input output, I don't need to like move data. But since we are following the example, we're just going to keep it like that. Okay, so once you initialize that at 0, you can check it to see, right? You set it up to check. Okay, and then you can branch if it's negative, positive, it's going to go to else. Because here, right, we want to set it up as equal to 0. So we initialize that at 0. So we can then branch it to else. Then let me fix this. I don't like using the LDR, like things don't just exist like that. So LDI R1, and we're gonna load Y. So we are going to do the load Y to R1. And then on the next line, we're gonna do an increase Y. Oh, this part here. And then we can store back. Ascii 1 to Y. C R2 to C. I guess you can use R1 again, but I'm going to use R2 so it's easier for me to track. Hold on 1 second. Let me see what we did there. Okay, so we are going to decrease So here, what they did was they take that and they add it with the 1, and then they store it by subtracting 2 because it's actually a decree of z. You can do it this way, or you can take that and you can add it with R2 with the -1, and then just simply do a store back without having to move it down 1. So STI R2 to Z, store Z. And this is a decree. Agreement of Z. Then for the else, so let's move this up a little. So since we send it to else, right, we have to handle the body of else is where we subtract y, and we would do the increment. Yes, you can use it like the code, assuming that you load X, Y, Z from R5, right? So I'm going to redo the load part here. Okay. So notice, okay. So earlier we talked about like how we copy in the previous exercise, right? It will probably be better to do it for this one as well, because in the else you have to reuse the X, the Y and the Z, okay? Because where I left off here, right, I had increment of the Y, so I cannot reuse it. So that means I have to reload it because I store it out, okay? But if I loaded it and copy it, I can reuse it for the else section. And so that's important to think about. So if you need to reuse that variable for another section, you might want to copy it to another register first, and then you can do whatever you want to do with it and store it out, right? So at this point, right, at the store out of Y, it has been changed with the register 1. So I probably have to reload it again, okay? So I'm going to just go with this and I'm going to reload it again. Okay. Or I can actually let me copy it. Copy Y2 R3. So I can reuse it. Same thing with here. R4, R2, and a #0. So I'm going to copy C2R4. Okay, so since I copy Y to R3, I can use that here. Okay, I don't have to do a load. I can simply do a decrement of Y. So we can take up this line and change this to R3. Then we can store this back to Y. Let me put that away. And then we store it And then again, we don't need to load Z because we copy it to R4. Now here is where we change this to R4, and we're gonna do an increment of C, I believe. Yep. And then we store it back to Z. 4 back to Z. Then we would do a halt, then we would then do a dot n, but before that we have to do a fill. So X is gonna be X dot fill at hex 3100. Y is dot fill at hex 3101, and Z is a dot fill at hex 3102. And you are set there. Okay, so let me pull this in a little. Oh, it's smaller. Okay, there we go. Okay, so to really review this, we have origination address. We load the X to R0. We initialize X as 0 at register 0. We branch for negative positive because we check the if statement, right? If it is 0, then we execute the body, which is the next part. But if it's not, we're going to send it to else. So we branch for else there. And we load Y, which is the body of if. And then we copy Y to register 3 because we have to use it for the else body. Then we do an increment of Y. Then we are going to then we're going to store Y. Then we're going to load Z to the register 2. We copy to register 4 for Z. We do a decrement of Z. We are going to store for Z. Then we set up the L section, and we're using register 3 and 4 for Y and Z. So we're going to do a decrement for Y, store Y, and we are going to set up the increment for Z and store Z. Okay. And then we end the program, we fill to check X, Y, Z. So we can test with the value there. And that is my version of the example in the textbook. Any question? So you can do the load and store with register the way that the book shows, right? But you still have to do the load with register 5 for each of the variable X, Y, and Z. Otherwise, how are you going to be able to use the simulator, right? To set the value. So to really cut out the LDR and the STR, we can use the LD or the LDI. You can definitely use the LD for this, right? I'm just in habit of using LDI. So if you want to do a load, you simply do a store. So you can do an LD and ST instead. Okay, so I use the LDI to load all the labels. I copy the register because I have to use it in if and the else section. And as the value change, since I didn't do any save register, I have to copy it to another register before I start using it. But if you do safe register, you just then store back from the register, and then you still have to fill to the label to check. So you can simulate. Okay. Any question? And so in the final exam, you will find that there will be some section where you would have to interpret the LC-3 code. It's not very lengthy, like a complete, really long lab program, but there are sections that you have to look at it and see what it's doing, like an if statement or, you know, some kind of arithmetic operations and so on. So you have to choose your answer based on that section of the code. So you do have to read that. And then applying this concept to your project, right? You have to implement conditional and iteration in your project, because in order to execute the program for bubble sort or count or anything like that, you have to implement condition and loops. Okay. Any question? Okay. You want to do the next one now? Are we ready for that? Okay, so let's look. I did this last year, so let me double check, because sometimes if I miss something, let's see. All right, so we are going to do the next one. Let me put the origination on there so it's complete. So we can run and test it. Okay, so this one, I front loaded everything here. So I load X to R1, Y to R2, and Z to R3. And then I want to, let's change this. You can add or you can clear it. So I'm just going to clear it. Lines X 0. So here, I initialize my X to 0 so I can check. And then in this case, I'm going to branch it to true. Okay. In the last one, you saw how we did the else. So this is like another approach. Okay. Then for R2, which is Y, I'm going to go, I don't like it like this. Okay. So if I take it and I decrease 1, oh, okay, I see what I did. So this is the L section now. Okay. Then I'm going to do the else, because if it's true, it's going to do this. So the true section has this. Okay, let me highlight it so you can see. Okay. So for the true section, we're going to do the body. It's the reverse. Now for the else section, because if it doesn't check true, it's going to execute the else here. So I would take the Y, and then I should just simply increment it here. And then I would take the Z, and then I would increment that there. And then I store the Y and the Z. And then for the true, okay, I should copy these. So hold on 1 second. I can just clear it out here because it's stored already. So we're going to do an N, R2, and a 0. And then N, let's handle R2 first. Okay, So we then gonna handle this part. So we're gonna increment the y, okay? And then we are going to decrement the z. And then we're gonna store it, but we need to clear the z. And R3, R3. I'm saying one thing and type the other thing, so I forgot a comma here. So we initialize this, and then we should subtract 1 here. We move back 1, we plus 1, we move back 1. Okay. Let me double check. Subtract. Oh, I had it in reverse. Sorry. There we go. Then we do a halt here. 2 and R3. R2. R3. Let's do this at 3100. Again, 3101. And then your Z is at 3102. Yeah, we don't want to use the 4, that's for stack. So 3102. And we are going to halt. And we're going to do a dot N. So I'm going to halt here. Okay, so this is a little different. Let me move everything down to the next page. Or this should be up a little. Yeah. Okay, so let's go from the top. Origination at 3000, load X, Y, Z to register 1, 2, and 3. Clear out register 1 to make it X equal to 0. Then we branch for true. We're going to check for 0. So if it is true, it's going to go to the true section. So we did it a little bit reverse compared to the last one. If it is not true, this is the else section. So we are going to decrease Y, increase Z, store Y, store Z. Then we set up the true label section. We clear out because we store out already, so we can clear out Y. So this. We clear out. R2 is still loaded. Oh, I forgot. I have to reload it because it's stored back here. Sorry. Oh, so we don't need this. So let me fix this. Sorry. I gotta do an LDI. R2 to Y. And then I've got to reload the Z. Yeah, because I store it here, so I have to reload it again unless I copy it like what you've seen in the last one. So I load the Y, I load the Z, then I store, I increase, decrease for Z, I increase for Y, I store the Y, I store the Z, and I halt. Okay, so this becomes the if for the if body, and then the above it is going to become the else. So it's the opposite from the last one. And then I fill and I have a dot N. Okay, any question? And so if you have a nested if, right, you can just set up a label like nest or something like that, or end if. And then you would also need to set up the branching for true or not true and be able to send it back and forth. Okay. So for something in 4 or 5 lines in C++ or C, we do see that it's 4 times that in assembly. Okay, so this is why it would be wise for you to start your project early and plan it out. So when you program, don't do it in like a couple sitting. I think if you set it up and then just come back to it and look at it again, it's probably a little bit easier to kind of see if you have some kind of logical error, or if you are missing something with a certain register and so on. Okay. Any question? So easily you are going to see your project is going to be roughly between 50 to 100 lines. Okay, so think about being mindful of your field addresses, and then make sure that you implement subroutines, make sure that you implement safe registers, make sure you fulfill the criteria in the project. Okay.
I have a quick question about the project.
Yeah.
Is there a preferable time we should begin it? Like, should we like listen to the next few lessons first before starting it, or?
Yeah, so we have another lab this week. Your lab is going to be on, so I want to show you stacks, okay, on how to set up a stack. That will probably be easier to start your project after you see it. Okay, so I think after this week should be good. Normally I release project about week 9 or 10 in a regular semester, because by this point, you should have most of the things that you need for the project, right? You're knowledgeable in a lot of the basics already. Like we talked about subroutine, how to define it. So I want to say after this week, you can begin your project, okay? And because we address everything that the project asks for, okay? So if you look at, yeah, go ahead. Did you have other questions?
Oh, I was just saying thank you.
Okay, yeah, no problem. So this week, sorry, I should have posted this a little sooner. I thought I clicked publish, but, you know. Okay, so oh, I thought I did this one as, let me double check. Okay, so we're gonna do a Zeller formula. This is revisiting the day of the week program that we did earlier in the semester, where we show like 0 is a Sunday and so on, right? And so we would implement Zeller equation to be able to output something similar. And it would be more efficient than the older program that you would see, because we're defining our subroutines. Okay. And yeah, I think we'll be behind 1 week. So let me see. Yeah, so I want to say, excuse me, maybe after this week or next week, because we have one more that's going to be the random number generator. This is going to be the one that has the stack. Yep. So after week 11, you know, you can write your program and start with that, and then you can set up your stack later on. Or, you know, if you have YouTube, my channel, you can also watch beforehand if you want. But in week 11, we're going to talk about the lab that's going to cover stack. Excuse me. Any question? Okay. So let's try 7. This is an example from the book, but I'm going to do it with you. Some of you probably had this already. Okay, let's start with that. Next 3000. We're going to load X. We initialize X. And then if you wanted to do it like them, because I copy it here for you to see, but you can also download the PowerPoint. And then you can test. So at this point, if you want to do, load and store, I actually, okay, I think it should be fine. Okay. So now we're going to test, right? We are going to get this. So, because we're now entering the while, and it's going to be X is less than 10. So what we need to do is, if we're here already, we can simply use R1. So we're going to do an add R1 with a decimal 10. Oh, I'm sorry, negative 10 to test. Then we can do a branch. So if it is less than, so when you subtract, just like here, if it's 0, positive, so we can do a ZP. And we can do it like that. We can send it to done. And if you look at done, that will just be like the next part, right? Which is halt. So now if it's not true, I'm sorry. If it's not true, 0 positive, then it's gonna go to done, which is halt. If it's true, then we want to operate this part. So if you look here, the guidance is that it's gonna load. We are gonna load X, and we're gonna do the print. Okay. So what we're gonna do is we are going to, because they did the load store, the store. Oh, they start with the store. That's why they load here. Okay. So now we're gonna handle the body. We need to do the print, and we need to show X. Okay. So that means that we need to copy whatever the X value is from here to display it. Okay, so we have to do the conversion. No, we don't. Yeah, if we set it, we don't have to do the up. We have to convert. I dread doing the conversion because it's like 4, 5, 6, 20 lines. Okay, so let's so we have X on register 1. Okay, we need to display X along with like this thing right here. Okay, but I wanted to do a little bit better than this, right? Because you simply need to out the X. So if you just want to out the X, you just need to copy it to register 0. So we are going to copy, add R0, R1, R1. Okay, so now we can say that X is at register 0. Why do I need to get it to register 0? Because I need to make it into a character, ASCII character, and then I can output it. Okay, Now, assuming that we had set this value as a hexadecimal already, we don't need to subtract, but we need to take that, the variance, the difference in the hexadecimal, and then convert it to an ASCII character. So what's my next step? Anyone know? After I get to register 0, how do I ASCII convert? Let's look at the ASCII table again, huh? Okay, so let's say that I already have X as a certain value, right? I know that the gap between the 0 to a decimal is 48. A 0 to a hexadecimal is 30. And I can choose. If I choose to use a decimal value, I need to add 48. If I want to use a hexadecimal, I just need to add a 30. Or I can fill an address with the hex 30 and then add it, right? Load it, add it. So if I choose to do the hex 30 or the 48, I need to make sure that it is in increment. I need to add it multiple times, correct? Because immediate value has to fit into the 5 bits. Okay, so go back to your prior lab and you can also take a look at it. So here, what I can do is I can simply do an add. R0, sorry, I meant to do this. Okay, so I would take an R0, and what's the value that I would add here? I can do a decimal 16, right? Because if I do it 3 times, that will make it a 48. And then R0, 16, add. So I have ASCII Conversion to character. So now what we can do is whatever the value here, it's converted, right? And then now I can out. Because I need to set this, right? And if you wanted to do a string like this, then you can do, an LEA to it, and then you would do an out. Let's do that so I can show you. So if I need to load the string, then I need to fill that string, right? Okay, with that character. Or we can even do better. We can say, X is. Okay, so we can say, let's say, let's use the label, let's say out, show. Excuse me. And we can fill it with, let's say X is. Okay. Then what we need to do is we would need to, right before this, R0 show. Then we would do an out. And then after we show, then we need to load the X. So then we would do LEA R0 X. Okay. And then we do another out. Can I put, can I do that? Can I load my, whatever the value is to the X? Or what do I need to do here to output the X as shown here? Because I need to print something and then show the X. What do you think? So I put the strings, I output the strings here. Display string. Then what do I need to do here? I have the value in R0 here converted, right? How do I load it to show the X value? What did we do before? Anybody know? Maybe 4 laps ago. Actually, we did that in lab. We do the out. Yes. Let's change that to the puts. But we need to do the out for I see some chat. So even set load it in and then out it. Yeah. So puts, you would use that for the string. So you can load it back into, I guess I can do an LDR on this. I'm trying to find like a more simpler, efficient way. So because we have it from here, we load it. We need to store it. We don't need to load it again because it's already in register. So we can take that and then I guess we can do either an LEA. We can probably do an LEA R0 with we can do an LDR R0. That's redundant. We can store it. We can start to. Yeah, I don't need to reload it because I loaded it here. I Ascii convert it. Right? I can simply load, I guess I can load it again, and then because after I load the string to R0, then I can load ODI R0 X. But before this, I want to store. You can store. Let me see what I did with the other ones. No, Ascii convert. I don't think I did the actual. I want it unregistered 0 though, because 0 is where I can actually out it. So this is a little sloppy. Okay, forgive me. Okay, so I'm gonna store the value. So after I convert it, I store it to X. So I can free up register 0. I load the display to register 0. I output it. Then I reload the X because I want that sequential. I want that string to show first and then the X value, right? I don't want the X value first and then the string. So the thought process is I need to get this to, I can keep it on register 1, then copy it to register 0. That's probably is better. See, sometimes I can't decide. This is what happens when I write your lab program. I just keep going back and forth like, oh, I need to fix this. Okay, so I branch it here. I think I'm gonna keep it on register 0 and then recopy it later. Okay, sorry guys. All right, so let me Ascii convert it right here. Okay. All right, so we Ascii convert it on register 1. Let's do this. Okay. And then we're gonna load. Actually, we can do an STI R1 to X. Then there we go. I think that I like this a little better. So I I kept it on register 10. I mean register 1. I subtract the 10 to compare so it can check if it's done, because we're using a label. It's not gonna like it if you don't deal with the label. Okay, if it's done, we're gonna make it get out, finish, end, right? It's gonna halt. If it's not, so if it doesn't check true, then we can Ascii convert it. We store it from register 1 to X so we can take it out and use it later. Then we're gonna display the string, then we're gonna load that to the register 0 so it can out, and then that's it. And then now we can fill. So we are going to do X is gonna be dot fill at hex 3100. Right, we only have X. And then and that should be right after that one, okay? And then we do a dot n. All right. It's still a little sloppy. I don't like it, but it is what it is. Question. Oh, I forgot this. X is equal to x plus 1. Okay. I thought I was done after that out. So we can take our add R0 with with the decimal 1, because you still have to take care of this right here. Okay. And so when you check with this program, if you run it, right, it needs, when you fill whatever you fill with X, and after you run the program, it's going to show whatever the value that you fill it with. But in the location, because the last thing that you had it done is to take itself and add it with 1. So it's going to increase by 1. And so when you look at 3100, it's going to be a +1 there. Okay, it's not actually the one that it shows previously. Yeah, I didn't like the criteria for this program, the way it's written here. It's like it doesn't make sense. But when you check the value at 3100 at the end after the program is ran, it's going to be a +1. But the output is the previous, because we had it output before this line. Okay, because the way it is here, it showed the printf of x, and then it's going to take x plus 1 is equal to itself. So, you know, at the location, it's just going to be a +1. Okay. So the example you can do, but you still have to fill in a lot of the gaps, as you can see, right? So the logic in that is, if we need to really output it on console, we have to make it where it's ASCII converted. Now, if you ask for an input, this is a real program, then we have to do an input. So we subtract 48, then before we output, we add 48, we load it, we show it, right? And then we add it with the 1, and then we end the program. And we halt, and then we end. All right, any question? Okay, let's do 8. Okay, one more. Actually, a couple more. Okay, so let's just do 8 and 9. Oh, we can answer all in the next 15 minutes. I'll make it fast. Okay, so for question 8, it says refer to the for loop for the C program, write a comparable program for the LC-3. Okay, it's only a for loop, so we're just going to do the snippet. You're going to initialize this part. You can use the example from the text. You initialize for I is 0, so your register 0 is 0. Then we would assume that if R5 has I, okay, yeah, okay, I'm gonna fill in one line because it's gonna bother me all the time. So I'm gonna do an LDI. So I'll miss a line. Okay, so let's do an LDI 0 as I. That's little I. Oh, capital I, it's good. All right. Okay, so I'm gonna load register 5 with I, so that way, you know, it tracks fine. Then I'm gonna store from R5 to R0. So now R0 has I, and we want to initialize that at 0, which we previously did. Okay, then we are going to load again our I to register 0. We're gonna subtract 8 because we have to check for 8 here. It is less than or equal to, so we're gonna branch for positive, gonna go to done. And so our done is gonna be halt, okay? Then we're going to load I again. And in this one, I have to ASCII convert because I need to get it ready. Okay, so we can ASCII convert this by subtracting, I should do 15, 15, 15, and a 3. Okay, for 48. So here, this is for, sorry, it's just misaligned. So this is for ASCII conversion. Then just like what we did last time, we're just gonna load it. R0 to, actually, we're gonna do LEA R0. I'm gonna do a store to R0 because we need to print the I, so then we're gonna do out or puts. I'll do puts for you. Okay. Then after that, since we have that printed, okay, then we're gonna do the increment. So we're gonna add R0 with the +1. Then we can do the store back to register 0. Then we can jump again for the loop. Okay, so we can keep that the same as what you've seen in the previous. The only thing that we added, the difference is gonna be, it's gonna be the ASCII conversion. So let me move everything to the next page so you can see the complete. And then if you want, you can fill it to test, but this is only a snippet. So that's just a section of your code. Okay. So this is the part for the output right here. Any question? It's just like the last time. The only thing is that we have to set up the beginning, the middle, like the start, the stop, and the update for the for loop. Okay, so now we have about 10 minutes. So we're gonna address number 9. And then for 10, you can probably answer pretty easy. So what are the primary differences between a do while and the for loops? The do, the test is evaluated after the loop body. Okay, where the for, the test is evaluated before the execution. So that's a big difference, right? So for the do while, the test is evaluated after. For the for, it's before. So for 10, when we look at this, we can say that the for loop, this for loop, it starts at 0. It's going to go up to, and it stops at 20. So it's going to loop 20 times. And we have a nested if. So it says if I mod 2 is 0, continue. And it's going to print I, right? So how many times it's going to do that? It's going to go up to 20, because right here it's equal to 20. And it's going to update each time. But when as it loops, it's going to check, right? For I is this. It has to check this condition. If it is true, it's going to continue, right? And then it's going to print the value of I. So put that in a paragraph or a couple sentences, explain what that for loop does. And that wraps up number 10. Okay. Any question?
Professor,
Uh-huh.
can you go back up to number 7 so I could finish answering that one? The other one with the enter underneath the LC program, LC3 program for number 7.
Yeah, this is number 7 in blue.
Oh, I thought there was another part to it.
No, that's
Huh?
no, that's it. Yeah. So let
All
me
right.
fix this. Yeah.
Thank you.
You're welcome. I had 16, but it's gonna overflow. So here. Sorry, I forgot that. That's how you should do it. So if you're adding 48, because we have to offset it by 48, you have to do it 4 times. You can use the hexadecimal, which gives you less lines. So yeah, this is number 7. Other questions? Okay, I'm gonna go ahead and stop recording.